Hello learners, welcome back to the course on construction methodology. So in this video, we are going to learn how a concrete patching plant looks, what are the different diameters of the vibrator that is used in the construction industry, what is the idea of using a vibrator, how a footing de-shuttering looks, and what is the importance of doing curing to the concrete. So as I already mentioned in the previous video, this is how our wave bridge looks. And this is a wave bridge, and we have a control room here. So here you'll be getting all the information regarding the weight of the vehicle, the load of the empty vehicle, and all. And this is how another wave bridge looks. So this is also a wave bridge. So your transit mixer is standing here. You're going to get all the information regarding the weight and the weight of the vehicle and the weight of the concrete. So this is a batching plant. This is how a batching plant looks. So we have a cement stored here, and we call this as a silos. And you have your transit mixer ready here to carry the concrete, which is a process from this plant. We call this as concrete batching plant. And what will happen, so we'll have another control room here in the batching plant. We'll be having a control room here. So this is a guy sitting in the control room. So you'll be having all the measurement. For example, if I need to prepare 1 m³ of the concrete, then how much amount of cement is required, how much amount of sand is required, how much amount of aggregate, that is 20 aggregate is required, how much amount of 10 aggregate is required, how much amount of water is required, how much amount of admixture is required. All these things will be having ready with us. We are going to do a design mix for that, and based on the calculations we are going to get all these values. So the person sitting here, he is going to input all these values. He'll have a system with him. They'll have a separate software for this, and based on that, based on the calculation that is done here, and based on the concrete that we are placing, that we are ordering, he is going to do the calculation, and he's going to give a all set option from here. And from here, what will happen, the process starts. Your concrete, I mean the cement, will come from the silos. Then you have this aggregates and sand, flowing through a conveyor belt, and water coming from here, and all things get mixed here. And finally, this is how your concrete is made ready. And with the help of this hopper, you get a concrete here, and from there it is passed to your transit mixer. So this is the entire process I've explained you in a brief way. So I hope you got a idea how a concrete is manufactured in the batching plant. So this is called as, now we'll try to see what is vibrator and what is the importance of the vibrator. So the concrete vibrator needle is also known as vibrating poker. It is available in various diameters, including 25 mm, you have 28 mm, 32, 35, 38, 45, 50, 60, 78, 75 mm. So these are the different diameters of the vibrator. So this is the vibrator you have. It's a small machine here, and this is called as vibrator needle. So the diameter is what I was speaking here, like 25, 28. So these are the different diameters of the vibrating needle that is available based on the different works. If it is a beam casting, we are going to use a different thing. If it is slab casting, we are going to use a different diameter. So based on the type of the work, we are going to change the needle of the vibrator. So these are the different diameters of the needle that is available. And so I'm going to play a video so that you're going to get an idea how it's going to work. So we have a concrete placed in this footing, and you can see here vibrator. This person is holding the vibrator. So what is the help of what is the use of a vibrator? The vibrator will try to distribute this concrete uniformly in all the places, and there will be uniform mixture of the concrete, so that each and every place you'll be having coarse aggregate, fine aggregate, and cement, and you're going to get a uniform mixture. So this is how it is. So even this guy is holding a concrete vibrator here. They have done the casting of the footing, and once or twice they're going to make this vibrator dip into this concrete, so that you're going to get a uniform mixture. So this is how it looks. So this guy is making use of vibrator, and is trying to make the concrete flow easily, because you have a junction here, right? I'll pause it for a while. You have a junction of column reinforcement here. So the chances of your aggregate getting into this is very less. So with the help of the vibrator, we are trying to make this concrete flow in each and every part, so that the load distribution and everything will happen in a better way. So this is how we are going to keep the vibrator needle, so that the concrete goes to each and every place. So there are certain precautions to be taken while pouring the concrete. So actually what happens here, this is the NGL level. If you can remember, this is natural ground level. And when you work in the small site, so whatever I was speaking so far, that is related for big industry. So imagine you're working for a small project, like you're constructing a small house of ground floor, yeah, G+1, where you have ground floor and the first floor. So in that case, we're not going to order the concrete from the RMC plant, and your transit mix is not going to come to the site. So we'll call the local contractor, and he'll be having a concrete mixer, and with the help of this wheelbarrow we are going to pour the concrete. So one thing we should remember, so this level is called as NGL, that is natural ground level. So now with the he's pouring the concrete here, but what will happen, there's a segregation happening. So again, what is segregation? If you can notice it here, you have a core segregate here, but the cement paste, that is, it is flowing here, and whereas the aggregate is still here. So as a result of that, what is going to happen? You're not going to get a uniform mixture. Of course, when you use a vibrator, you're going to get a uniform mixture, but this is not the right way, or you can say right practice of pouring the concrete. So whenever we are pouring the concrete, we should make sure the height between the NGL, that is natural ground level, to the depth of the footing is not more than 1.5 meter, or it should be less than 1.5 meter. So this is the right way of doing. Otherwise, the other option is that you should use an incline shoot. If you can remember it from the previous video, we had used an incline shoot, right? With the help of that incline shoot or a wooden shoot, you have to place an incline shoot here, and then you have to pour the concrete. So that is the right way of pouring the concrete. Otherwise, you are not going to achieve the required quality of the quality of the concrete that is required at the site. So this is a wrong way of practicing. So always try to pour the concrete from the height less than 1.5 meters, so that no segregation is going to happen. Otherwise, what will happen? Your cement paste is already here. Your aggregates are into this. So these aggregates are going to come back late. I mean, they are going to fall later. Again, you have to make use of the vibrator. So you're not going to achieve a very good quality of concrete here. So otherwise, ultimately, what is going to happen? This is a case of a column. So usually in footing, this doesn't happen. But if it is a case of the column, that I'll be explaining in the further slides. So this is how it happens. What will happen? Your cement paste has already gone through this as passed through the shuttering, and you can see only the aggregates here. So this is not going to take the load that is coming on this. So we call this as honeycombs. So this is a bad way of pouring the concrete. So this should not happen. So that is why it's always better try to pour the concrete from the height less than 1.5 meter, and try to make use of the vibrator, so that there is no so that you're going to get a uniform mixture. And also you should keep one thing in mind, you should not use excessive vibrator also. If you're using vibrator for more time, again the cement paste which is there, it's going to flow out of the shuttering. So that also should not happen. So always you have to try to adjust in between this. So make sure these honeycombs are not observed in your structure. And so the better way, as I mentioned, is bring this wheelbarrow. Try to bring a wheelbarrow, and with the help of this incline shoot, pour this concrete, so that this guy will try to pull it, and then you can make use of a vibrator. So that is the right way of doing. So when we work in a small projects, we have a tendency of pouring it from a um, wheelbarrow, and the local contractor doesn't make use of all this incline shoot, which is again a wrong way of practicing the things. So it's not a right way to do. So it's always better you try to put an incline shoot, so that you're going to get a uniform mixture, and then you can make use of the vibrator here. So now we'll try to understand this particular plan. So imagine you have, there's a footing here, F1 by name. So the size of the footing is 4,200 mm into 4,200 mm, and D is the depth of the footing. So we'll try to see what is the depth of the footing. In the same way, we have another footing, that is F2. The size is 4,400 by 4,400, and depth of this footing is 450. Similarly, we have F3, F4, and F5. Once we pour the concrete, once the footing is done, this is how your footing is going to look, right? This is how a footing looks. So I'll consider this footing. This is my footing. I done a shuttering. If you can remember, I done a shuttering, and this is my, say this is F1 footing. This is F1 footing, and the size of this footing was 4,400, 4,200 is the length, and also 4,200 is the breadth of the footing. That we saw it from the previous slide, where we went through F1, F2, and F3 footing. So this was F1 footing. The size is 4,200 by 4,200. So this is the depth of the footing. The depth of the footing is 450, because it was already mentioned. I'll try to go back again. So it was F1 footing. The size was 4,200 by 4,200, and the depth was mentioned as 450 mm. So that is what I'm trying to show you here. So F1, and this is the depth of the footing, that is 450 mm. Similarly, we have another footing. The name of this footing is say F2 footing, and the size again it is 4400 by 4400, and depth of this footing is 450 again. So in the same way, if you can remember in the previous video, we actually had planned to do the 16 footing casting per day. So this is how your plot looks. If you had planned for 16 footings, you have first footing here, second, third, fourth, fifth, sixth, and so on. So whatever 16 footings you had planned, and based on the drawing, you're going to get the name of the footing as F1, F2, F3, and all. And this is how all 16 footings looks. As of now, there is no 16 footings here. So imagine you have done a 16 footings. So this is how your site looks. So this is how the progress of the execution happens. So once the footing is casted, the next thing is to de-shuttering of the footing. So what is de-shuttering? So de-shuttering is a process of removing the wooden or steel board after the concrete has gained desired shape and strength. The footing shuttering can be removed within 16 to 24 hours from the time of casting it. So this is how it looks like. Now in the previous slide, we saw that this footing was with the steel, I mean the steel shuttering or the wooden shuttering. Now what we have done, we have removed the shuttering. So after how many days you have to remove that, that we are going to see that we are going to see in a while. So this is how your footing looks, right? So imagine you had plan of 16 footings. Again, this is 16 footing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on. So you have removed all the board that was kept here, because the intention of doing the shuttering was to give the shape to this footing and to make this concrete stiff and to take the load on it. So once the casting is done, so this is what is mentioned in the clause books, that is code books IS 456-2000. If you belong to some other country, you will have a different code book, and from that code book, you can take it into note. So the type of the formwork, it's written here as vertical formwork to columns, walls, and beams. So that means it's a vertical element what we have done for the footing. So that is why we consider this into the this section only. That is vertical formwork to column, walls, and beams. And what is written here? Minimum period before striking the formwork. That is how many hours or how many days is required before taking this shuttering out. So it's written here as 16 to 24 hours. That means 16 hours, or you can make 24 hours is one day. So imagine the time is 5 o'clock now. You are done the casting at 5 o'clock today. So tomorrow in the evening after 5 o'clock, you can remove this shuttering. Otherwise, the usual practice is we don't wait till all 24 hours. We are going to take it off after 16 hours, because it's mentioned as 16 to 24 hours. It depends, how big your how big the footing size is, what is the depth of the footing. So if it is small footing of 300 of size, like say 3 meter by 3 meter, we can take it off after 16-17 hours. It's always better wait for a day, like evening if you're casting around, like morning if you're casting around 12 o'clock, then next day you can come in immediately in the morning and take it off around 11 o'clock in the morning. So that means you're doing almost 23 hours of shuttering you're keeping the shuttering for 23 hours. That's a good way to do. But it's always better you follow the code books. It is written as 16 to 24 hours. You can take it out after 24 hours, or you can take it out after 16 hours, like 17 or 18th hour. You can do the de-shuttering of the footing. So this is how your footing looks. So once the de-shuttering is done, so this is how it looks. This is a photo of another footing. If you can remember, we had done the excavation, then we had placed a PCC here. This is how a PCC looks, and this is the footing. So this is a quite slope footing they have given. So nowadays we don't go for slope footing. So the better footing is the isolated. This is how isolated footing looks. So we have a PCC here and we have a footing here. This is how it looks. So finally, the curing of the footing. So what is curing? A curing is a process of spraying water to the surface of the concrete. So curing is done to keep the concrete surface moist and avoid loss of moisture from the atmosphere. For footing, usually 5 to 6 days of curing is done. So what is curing? It's a process of spraying water to the surface of the concrete. Because what happens if you don't do the curing uh, uh, of any element, that it can be a footing, it can be column, it can be slab. What is going to happen? Already there is water into the concrete, right? And the strength gain of the concrete is after 28 days. So if you're doing the footing, or if you're doing any concrete work, it is going to take 28 days to achieve that particular strength. When I say I'm casting M20 grade of concrete, the strength of 20 that is achieved after 28 days. So for all the 28 days, your concrete will be slowly gaining the strength day by day. So there's already water present in the concrete. So if you're not keeping the surface of the concrete moist, I'll go back to the see. Uh, so imagine you've done the casting of this footing and you're not pouring the water over this, what will happen? There's already water present in this concrete, right? There's already water present in this concrete, that we have seen it from the batching plant, and that we have done the workout. If you are taking 1 m³ of the concrete, this much amount of water has to be poured. So once you pour the water and do the casting of the footing, it's not that suddenly the next day all the water is utilized by this particular cement. So it will take day by day, it's going to utilize the water that is there inside the concrete, and then it's going to give the strength. That is why we say concrete is going to take 28 days to gain the strength that we have put in for. For example, if M20 grade is used, that M20, that is M stands for mix, the 20 is the strength that is required. So that 20 strength is going to achieve only after 28 days. That means at the end of one day, you're going to achieve 2 Newton per mm square of strength. Say after 7 days, you're going to achieve some 7 Newton per mm square of strength. At the end of 14 days, you're going to achieve somewhere, 14 Newton per mm square. And at the end of 20 days, you're going to achieve more than 20 Newton per mm square of strength. So that 28 days, you have to wait. For that 28 days to wait, your concrete is going to gain the strength day by day. So already the water is present in this concrete. So if you don't keep this surface moist, what will happen? Because of the sunlight, whatever water is present in this concrete, that is going to get evaporated. If that gets evaporated, the main idea of putting the water was to help the process of the hydration, to help the process of this concrete, right? To gain the strength, we had put the water. If you don't do the curing of the concrete, the atmosphere, because of the sunlight, whatever water is present in this concrete is going to get evaporated, and whatever strength we want, that is not going to achieve. So in order to take that into account, what we are going to do, we are going to pour the water on the footing, so that even if the sunlight comes, that sunlight will make use of the water which is present over the surface of the uh, concrete, and not inside the surface of the concrete, right? So that water is going to utilized by the concrete day after day. Like for the first day, it's going to utilize little water, and then after 2 days, 3 days, it's going to utilize that water. So because of that reason, we are going to keep this surface moist. So even if sunlight comes, it's going to absorb the water which is over the concrete, and not the water which is inside the concrete. Because the water which is inside the concrete, that is to be utilized with the concrete or the cement particles for its hydration process. Only after that, you're going to get the strength that is required. So that is the main idea of curing the concrete. So this is how it looks. We have done the footing casting. Now we are keeping the water here, right? This water, even if sunlight comes, if this water is utilized, or if this water is evaporated, it doesn't matter to me, because the water which is inside the concrete, that should not be evaporated. Because of that reason, what I'm going to do, I'm going to pour the water into this footing, so that the loss of water will not happen from the inside the concrete. So this is how you can, this is a local practice what we do. You keep a gunny bag here, and you keep the surface moist. Again, the side, even the sides, you have to pour the water. Sides you cannot keep the gunny bag, but you can keep on sprinkling the water for every 1 hour or 2 hour. And this surface, since it is horizontal, you can place this gunny bags, and you can pour the water here, so that this entire surface is moist. So even if sunlight comes, it's going to make use of the water, which is, I mean, the water is going to get evaporated, which is at the top surface, not the water which is present inside the concrete. So that water is actually your designed water that is required for the complete process, for the I mean, for the hydration of the concrete. So this is the main idea of doing the curing. So thank you, and we'll see you back in the next video.